Hello, it's Keith here, and this is lesson 28 of the platform-specific series of my 6502 assembly programming tutorials. We're looking at the Super Nintendo again for the second week this week. Last time we looked at how to install some software on the SPC 700, which is the sound processor of the Super Nintendo, and the software was very simple. All it does is it takes 2 bytes. One is a register we want to change, and the other is the new value for the register. We had to do this because the 65816 can't directly access the sound registers, so we have to talk to the SPC 700 processor to do that. Now, if you didn't see that episode, please go back and take a look. But if you are just interested in the registers, this episode's going to work fine on its own. And of course, you can download the source code for today's episode and just compile it and run it and use that fine on its own. So let's start by actually seeing the code we're going to run today. So in all of these tutorials, we've been writing a little program which is called ChibiSound. Now what ChibiSound does is it takes a single byte, and you can see the value here in the accumulator, and the top bit is noise enabled disabled, the next bit is high or low volume, and the remaining 6 bits are a pitch. And this is designed for very simple sound effects for your Pong games, your Space Invaders. I used it for Grime 6502, so that's what it was designed for. And you can hear it making a wide variety of very loud noises there. So that's what it does, and that's what we're going to program today. So all we do for running ChibiSound is we call ChibiSound, we set the accumulator, and we're just decrementing the accumulator repeatedly here, and then we're just showing the current accumulator so that we can see what's going on. That's what we're going to be doing, and we're going to be developing that ChibiSound today for the Super Nintendo. Now, as I say, the byte in the accumulator, there are 6 bits for the pitch, 1 bit for the volume, high or low, 1 being high, and 1 bit for the tone, 1 being noise, and 0 being a normal tone. So that's what we're going to be developing. Now, as a bit of a special thing with the Super Nintendo, we actually need an initialization routine. The other systems don't need this, but the Super Nintendo does. So let's take a look. So here's the ChibiSound on the Super Nintendo. So the first thing we are doing is we're running this initialization routine. We did briefly see this last time, but let's take another look. So what we're doing is we're loading in the program code into the SPC 700, and we're loading, this is the code that actually changes the registers for us, so we're loading that in first. Then we're telling the system we want to do another load. This is sending a command to our program code, and we'll have a look at that in a moment. The next thing we're going to do is we're going to load in a second piece of data we want to send, and this is going to be the sound bank, which is just a single sound sample in this case. We're going to load that into memory address 300. Our program is at 200 and our wave sample is at 300, and these addresses are within the 64K of SPC 700 dedicated sound memory, nothing to do with the 65816, and that's the whole problem. The 65816 can't access the registers or the memory of the sound processor. So we're then rolling into this send sound data function, which is sending the data. We looked at this last time, it's quite long, so we're not going to look at it again this time. So about that sound sample then. So we need to specify some sound data. Well, here's the sound data we're defining. So we need to specify firstly a index of the sound samples in our file. And we've just got one sound sample. The first one is the initialization and the second one is the loop here. So we've got 2 definitions for our first sample here. Now you'll see there's some weird calculations here, and this is because we need to recalculate the address offset of the sample here. So our bank starts here, and here's the sound sample we want to reference. So we're subtracting the address from the start to calculate the offset, and then we're adding that to the destination address that this is going to be within the SPC 700 memory. This effectively means that this is the address that this will be in when it's stored at address hexadecimal 300 in SP 700 memory. You could do this other ways, but that's the way I've decided to do it here. And the sound sample itself is built up just here of a number of 9-byte sections. So if we had a second sample, we'd have another pair of these just here. Every sample has to have 2 of these. The first one for the initial part, and then the second one for the loop. But in our case, it's all just loop. Very simple sound sample. Now here we've got a header here. So we've got a bit shift element here, because this is an add PCM format. I can't, it's too complicated to go into here, and it's not something I've really looked into. So we're just creating a very simple sound wave here. So this is a bit shift, and then we've got a filter here, so we're just setting these to 0, 1. Then we've got L, which is the loop, and we've got that set to 1 here because we're just looping this one sound sample. And then we've got E, which is the end. Now you see we could have multiple sound samples here. Obviously we've just got one set of 8 bytes here, but we could have 800, as many as we wanted, but the last one has to have this end bit set. So that's how we're doing things here. So we've got our header, we've then got our add PCM data here, which is 1 nibble per sample. And so this is just creating something resembling a square wave, just so we've got a sound effect, because if we've got no data at all, we can't hear any sound. So this is just a real simple starting point for our sound. So all of this, the sound samples and the program code, is loaded in by this initialization routine here. Now, once we've initialized the system, we need to set some volume settings. We're going to be using some process sound command functions here. You can see we've got a few. One that takes a value from X from A, one that takes in a 0 value for X, and all of these end up in the exact same place just here. So the process sound command function here is talking to the code that we wrote last time. Now, if you remember, the code we wrote last time will take a value of 3 as a command stored to 2142, and that will tell the system we want to change a register. Alternatively, it can take a 2, and this will tell it we want to send more data. Now, you may remember we just saw this reload sound command function in between the first load and the second one, and this tells the firmware to restart reading data. But anyway, most of the time we're going to want to use this function here. So what this does is it stores A as the register number we want to change, and X as the new value for that register. Alternatively, if we just want to store 0, then we're setting X to 0 here just quickly to store a value of 0 into the register, because that's something we'll want to do quite a lot. So just a little bit of a saving there. So first of all, we want to turn the echo off. So we said changing 2C to a 0 here. Let's have a look at 2C. So here are our registers here. So you can see 2C here is the volume left, and we're setting that echo volume to 0 here. And then we're doing the same for 3C, which is the alternate channel. So we're doing that pair at the same time. Now, I've made this slightly confusing here. I should have probably made that as a 0 here. The X will already be 0 because this one's just run, but that's not very clear. So we'll do it that way instead. So we're setting both the volume echoes to 0 here. Now what we're going to do is we're going to set the left and right channels 0C and 1C to maximum volume. Now here are 0C and 1C. These are the main volume of the mixer, and the maximum is 127. So we're loading 7F here into X. We're loading the accumulator with 0C and 1C, the registers we want to change, and we're using process sound command X to send that new value to those registers there. Okay. Now we're defining something known as the source directory. It's a bit over confusing, but it's actually the address of the table that defines our sound samples. So effectively the address that this goes to within the SPC 700 memory, and that address is 0300. Now it's got to be byte aligned, so 0300 is stored as 03 here. So we store that into 5D, and 5D is this one just here. So we're storing that as the new address of the data, the sound wave data. Okay, now we are setting echo to off here. So we're changing 4D just here. So we're disabling echo on all of the channels. And this now puts us in a position where we're ready to start actually using our sound. So this was just the initialization routine. Now we are going to start with the ChibiSound function. So the first thing we're doing here is we're checking if the accumulator is 0. If it is, then we want to turn all the keys off. Now, if we want to control the keys, we can use keys on to push a key down and key off to lift a key up. Now, you got to think of this like a synthesizer keyboard. If you press a key down, it will make a tone, but if you release it, it doesn't immediately stop. It just sort of fades away. So we've got down and up, and there's 8 bits in each for the 8 channels of the sound system. So we are just lifting the keys up to silence it, or we're pressing them down later on to turn it on. Now, at this point, we're flipping the bits of the pitch just because that's the way the Super Nintendo needs them. It's the opposite way of some of the other systems. So that's just to make sure ChibiSound makes a consistent sort of pitch for all of the systems. Okay, so now what we're doing is we are resetting the keys on function here, just to clear that out. And then what we're doing is we are setting the flags and the noise clock here with 6C. Now this is one we will use later if we're making that noise effect, so at the moment we're just clearing it so that we can make a regular tone. Okay, so now what we need to do is we need to check if we want to make a noise effect or not. So we're checking the top bit here and we're branching if the top bit is 0. So we're skipping down to here if it's 0. If it's not 0, then we want to make a noise tone. What we're doing here is we're turning the noise on with 3D. And this is the option here. So each bit is a different channel. So you can see here we've got bit 0 set. So we're setting channel 0 to turn the noise on here. Now we're defining our noise here with 6C, register 6C here. And so effectively we're just defining the noise clock as we need here. And so what we're doing here is we're taking the accumulator that was passed to ChibiSound, we're taking these 5 bits here, we're then shifting them to the right, and we're using that as a new noise clock for 6C here. So we're effectively setting these bits here with the noise from that was passed to ChibiSound. Now we jump down to here. If the noise isn't in process here, then we're actually just clearing that here by setting 3D to 0 instead to turn that noise off. Once we've processed the noise, we now want to set the pitch of the tone. So what we're doing here is we're working on the registers that relate to the channel. Now, in all of the example here, we're using channel 0. Now, these are the channel specific registers. You'll notice here there's a little C, C0, C1, etc. Now, this C here would be replaced with the number that is relevant to the channel you want to change, so 0 to 7. So, if you wanted to change the left volume of channel 0, you would use register 00. If you wanted to change the left volume of channel 7, you would use 70, and this would be 79, and so on. And of course, there's no register relating to the channel above 9, so 0C has nothing to do with channel 0. You can see the C's and the D's and the F here. These aren't related to channels, but any number below 10, below A effectively, in this definition here, in the register number here, is meaning it's a channel specific register, and so these are unique to each channel. So we're always going to be working on channel 0 here. So here we're setting the low tone, and this is because the tone is a 16-bit number. So here it is, we're setting the pitch. Actually, I lied there, it's a 14-bit number. And so these are setting these two registers here. The tone is a 14-bit number. Now we don't have that many bits, so we're just using these bits from our definition and storing those in the high part, setting the low part to 0 here. And now we're setting our volume. Now again, we've only got 1 bit in our definition, so we're just taking that 1 bit and we're setting all the other bits to 1 so that we have a high volume and a low volume. Now we need to set that to the left and right volume of the channel. We need to set them both. So we're doing that with register 0 and 1. Again, we're setting the channel 0 volume here. So we're doing that twice. Now, of course, X is set the same for both times. So we're just changing the register here we want to change. And now we want to set some of the others. So we need to set the source number. This means the sound sample. So we're using the first sound sample, so we're setting that to 0. And that will point to this sample just here in this bank. Next, we're setting this ADSR. Now this is relating to envelopes. An envelope is the way the sound volume changes over time. Usually, sometimes it's pitch as well, but we want to turn that off. We want a constant even tone, so we're turning that off by just writing a 0 to register 5 for the channel. Now we've now set up everything we need for this sound to play. So the last thing to do is to press the key down. So we're again using that register 4C, which is just here, which is key on. And so we're setting bit 0 to 1 here, which will press the key down. So there we go. So that presses the key down, and that's when we will actually hear our sound. So there we go. Quite a lot of code there, quite complicated. Unfortunately, this is just the way we have to work with the Super Nintendo. But if you're not wanting to use ChibiSound, and I'm not suggesting you should, then the basics of this is load the X register with the new value, load the accumulator with the register you want to change, and call process sound command X in my sample code, and that will quickly set the register for you. Now once you've got some code that actually works, of course, you could start to get more adventurous. Or, you could convert this ChibiSound driver into some native SPC 700 code if you wanted to save performance or something. I wouldn't suggest it, it's going to be a lot of work, but of course that would be more essential if you were trying to write a music driver or something. But at least if you've got something very crude like this, you can play with the registers and see what's what. Because, you know, if you remove some of these commands, all of a sudden you'll find you've got no sound playing at all. Like, for example, if I rem these out, now I've got complete silence, and that's because I've forgotten to select the source memory address of the sound samples, and so I've got no valid samples. So, you know, as I say, this is nothing special or clever, but you've got to have something to start with to start to actually, you know what the system's supposed to work like and to know what the valid settings are. So hopefully this will be of some help to you. But as I've said before, there are dedicated sound drivers, I believe, for this system. So if you're looking to do something more serious, maybe you're just best off downloading one of those instead. Anyway, I hope you found this interesting. Thanks for watching today, and goodbye. Now, if you have questions, comments, or suggestions, please feel free to sign up to my web forums. Every tutorial episode has its own section on the forum. If you just click on these buttons here, you'll see it goes to a matching page of my forum. The forum's just at chibiacamas.com/forum. It's free to sign up, of course. You can show off your projects you're working on. I totally encourage you to show us what you're working on. And if you've got any questions, any suggestions, please let me know them. It's purely an assembly forum. So if you're working on assembly programs and you want to show them off, please sign up and show us what you're working on. Thanks a lot.